Hello, geometers and seekers of general truth. We conclude our lesson on lines and transversals with a problem that's a little bit more complicated. Complicated because it uses two different transversals here. So you can see that we have two parallel lines, that's in the picture, but there's also two different transversals. There is this one right here that I will slowly highlight in red. Right, that's one right there. And then there's another one right here that I will highlight in yellow. Okay, and if we try to look at these both at the same time, it can be a little bit overwhelming. So let's just look at one transversal at a time. And just to make things a little bit easier to see, I'm going to highlight the two parallel lines in blue here. So we're going to ignore the second transversal for right now and just look at the blue line and the red line. And right off the bat, one thing that we can see is that this angle, let me highlight some angles here. This angle here, y minus 8, and the one that's 124, those are supplementary because they form a linear pair. Okay, so even without using anything that we learned in this lesson, just the fact that we can see that they're linear pairs, we know then that y minus 8 plus 124 must be equal to 180 degrees. Again, because those two angles form a linear pair. So now we can simplify. Negative 8 and positive 124 would be 116. Subtract 116 from both sides and we get that y is equal to 64. I almost messed this up. Let's see. Y plus 116 is equal to 180. And then we can subtract 116 from both sides and we get that y is equal to 64. So we're done with that part of the problem. Okay. But I'm actually going to stay with this transversal for a minute here. And I'm going to point your attention to, let's erase this old highlight and let's point your attention to something that is also helpful here. So if we look at the angle that's 124 degrees and this angle right here that I'm shading in green here, those two angles are consecutive interior angles. So that means they must be supplementary to each other. Okay, so this angle here, I guess I'll call, I don't want to make it other variable, but this angle here must be 180 minus 124, which is precisely 56. Okay, so this angle here is 56. Now, the angle that's vertical with that, this one down here, okay, the angle that's 56 and this one down here, they're vertical angles with each other. So this must also be 56 degrees. And what you can see that I'm doing right now is I'm not even trying to solve for x yet. I'm just filling in information that I do know to be true. So now that I have that in there, we can go back and we can look at a different transversal. So rather than looking at this one, we can look at the other transversal now. And so much of this is just, it comes down to visualization. The more that you could see the problem in a different light, in a different point of view, the easier it is to solve it. Okay, so we know that this angle here is 60 degrees, and this angle right here is corresponding. Right? These two angles here are corresponding angles. So this one must also be 60 degrees. Okay, so by the corresponding angles postulate. And so now things have gotten really messy and complicated, but I have some angle measures that I figured out. And so I'm going to erase all this other stuff so that you might be able to visualize things just a little bit better. I'm going to take away all of this extra shading and all this. I'm just going to leave the angle measures in place. And let's see what we have right here. We have three angles: the one that's 60 degrees, the one that's 56 degrees, and the one that's 2x. Okay, those three angles together they form this wonderful straight line. They form this straight line right here, right? That's a straight angle. So now we can say that 60 plus 56 plus 2x is equal to 180 degrees. 60 plus 56 plus 2x is equal to 180 degrees. And so let me simplify all of my work. 60 and 56 gives me 116. I can subtract then 116 from both sides. So 2x is equal to 64. And then x is equal to 32. And there you have it. This concludes this problem. And I hope what you can also see is that the problem may be complex, but they're definitely solvable. And it's about using different strategies. And one of the strategies that we used is to look at one transversal at a time. If you try to look at all the angles at the same time, the picture is pretty messy and complicated. So you want to look at one particular transversal at a time. That'll help us. And just to start filling in some information, right? I didn't know exactly how to solve for 2x at the beginning. So I just started figuring out this angle here is 56 and using some vertical angles. And there's certainly more than one way to go about this problem, but I've certainly showed you one of the methods. As always, keep working hard even if you struggle. Take the problem as far as you can take it, and then once you're stuck, ask for help. Thank you for watching and have a wonderful day.